So here's the webinar contents. So what we're going to be going through is the modelling of the bridge, then we'll be looking at the application of loads and boundary conditions, the analysis capabilities, results extraction, design capabilities, and also the design report at the end. Here we have today's example. So as you can see, it is a 40-metre single span integral bridge. It is 14 metres in width. We have abutments which are 5 metres in depth and piles which were 1 metre in diameter and 20 metres long. The depth of the abutment is 1 metre, and for this example we've also set the piles at 1 metre as well. We also have a tapered section at the left hand end of the bridge and also the right hand end of the bridge. So this is the section on modelling. We'll go into the modelling space in a moment, but just to give you an inkling of what we're actually going to do, we're going to first of all look at materials and sections, then we're going to look at the composite bridge deck with the tapered steel girders and the reinforced concrete slabs on top. Then we'll look at the automatic creation of the tapered girders, and then we'll look at the steel crossbeam members and the reinforced concrete abutments, and then the piles, or the modelling of the piles. So I'm just going to drag across the MIDAS Civil user interface. As you can see, we have the ribbon technology at the top. Let's go from left to right and just show you those. So there's structures, and we're going to focus on now is our beam wizard. So just a quick girder. So it's 40 meters in length, and we're just going to put a nominal material. There you have it. Now what I'm going to do is I'm going to translate this and create 3 other members. So just translate this, just put the distance in 3.5 meters. Make sure I put it in the right direction. Okay, do that 3 times. So we just want to copy all the node attributes over. You see there, we've got our 4 girder beams, or the frame. Now we're going to create an element. We're going to create a cross member. Now I'm going to translate that quickly. So this is for, we're going to do it for every 2 meters, and as it's a 40 meter bridge, it will be 20 times. We're going to just copy all the node attributes. Make sure it intersects. Now is our grillage model. So we're just going to do some materials. So I'm going to add the 1 material, and then I'm going to import the rest. So from the drop down menu you can see the different materials. We've got the different codes as well for the materials database. We also have the sections, so I'm just going to quickly pick an I section, click OK, and it adds it to the list. Then I'm just going to load up a previous model and take the materials and sections from that. Okay, so I've just brought those in. Now I'm going to do the same for sections, so just to add one quickly. As you see the section properties. Okay. So I'm just importing the sections database now. As you see, we've got all our members, our cross bracing piles, our dummy transverse beams, everything's come across. We've even got our taper sections for the left to right and right to left, which I'll show you in the modelling space, and we have our mid span as well. I'm going to show you the modification of that. So you see some of our section parameters for the slab, i.e. the slab thickness. We've also got the same for the girder as well. These are the selection for our composite section, so we select the concrete and also the steel, and it automatically calculates the elastic modulus. And here we have our section properties. So you've got the values there before and after. So now we're going to do the cross girders. So I'm just selecting them. Gen has many selection functions built into it. Right, so we're just dragging, dropping from the works tree. So we're going to do the cross bracing now, and these are every 5 meters. 8 meters, sorry. We have 5 at 8 meters. Okay, just drag and drop the materials across. Then we go into the realistic view, and you can see the offset's been automatically changed. I can just show you that in the properties, and we can change the offset and put in the number or the unit length. So just going to isolate the midspan, and we're going to focus on making the tapered sections at either end of the structure. So from left to right, I'll just drag and drop that there, and from right to left. Then I'm going to use the tapered group to modify that and make it tapered so they all come to one group. So just to quickly, the left taper, polynomial, we're going to the jth end, and we're going to do the opposite and call that right taper. Go to the ith end, just add that, and as you can see it's now curved. So now we're going to extrude the abutment. So this is 5 meters in height, and we're just going to take the line to a planar element. So we just select the concrete, and we just select the thickness. I've not got the thickness selected, so I'm just going to quickly add that. So we're just going to make that 1 meter in depth. Just close that, and now we have our thickness section. So we have it for 1 meter in length, and we'll also have that 5 times going down the abutment length. This will be good for our soil structure interaction later on. So now we're going to do the piles at the bottom, so node to line elements. We just select the pile, we've got 1 meter diameter piles. Then we'll do it 2 meter intervals, and they'll be 20 meters in length, so we'll times that by 10. Okay, there's our pile there. Now we're going to do the soil structure interaction for the piles. So we're going to go quickly back into the presentation. So these are the loads and boundary conditions we're going to put on the structure. So it'll be the soil structure interaction of the piles that I just previously mentioned. We're going to do the earth pressure on the back of the abutments, and we're going to have the generation of construction stages, and do the creep and shrinkage effect as well, encompass that. And we'll have the automatic load optimization to Eurocode as well. So I'll just go back into the presentation. So now we're going to go back into the modeling space and look at applying the boundary conditions. So I'm just going to select the piles at the bottom of the structure and do the pile spring supports. So looking at that in the realistic view. So here is our boundary conditions in the form of pile spring support. So what we're going to do we're going to create 2 different strata. So we're going to have a stiff clay on the top and a sand material on the bottom. So we just select the top 4, and we give it some of the ground level. So we want the ground level to be the top meter there. Then we have the pile diameter as 1 meter. Then we put the coefficient of subgrade reaction, which we just set as 10,000. We just click apply, and then we're going to do the same for the bottom of the pile. So we select the 4 sections there, select it as sand, give it the modulus subgrade reaction again, and just click apply. Now what we're going to do is duplicate this onto the other end of the structure. So we're just going to translate that. So I've just selected it, and just to go to element translate. Okay, just put the distance. Just copy all the element and attributes, including the boundary conditions. As you can see, it's just been translated to the end. So we just want to display the boundary conditions there. So now, because we're dealing with the construction stage analysis, we do the creep and shrinkage effect and also the compressive strength of the material. So I'm just going to do the creep and shrinkage first. So I've already actually said it, so I'm just going to carry out a modify. Just show you can do it as a European standard, and you just select the characteristic compressive cylinder strength along with some other parameters, and that is the creep coefficient curve being drawn there. And we've also got the shrinkage strain curve as well. So just looking at the compressive strength, so we just add the compressive strength, the mean compressive strength, the concrete, and we just carry out the redraw there and click OK. So now we just look there, we're going to go to another model and carry out the construction stage analysis and also put the earth pressures at the back of the abutment walls. So just going to look at it in the hidden view in a moment. So here's our static load cases. So we're just going to create it for earth pressure. We already have them for the parapet, the temperature loads, the surface loading. So just looking at the earth pressure load, we select it from the comprehensive drop down menu. Okay. So looking at hydrostatic pressure, and just want to select the earth pressure or the load case. I'm just going to put, we just need to select the plates or the abutment walls, and we'll look at the reference points at the top. We just put the constant intensity or the gradient intensity as well. And as you can see, the pressure has now been applied to the back of the abutment structure. So now we're going to move on to look at the construction stage analysis. Oh, sorry, we're just going to, I better just do the self weight first. So just set that as -1. I'm just going to add that. Okay. Now we're going to do the element loads to the bridge deck. So I just want to select the bridge deck. I'm going to isolate that. So we're going to have different loads. We've obviously got the parapet load, the surface loading, and the wet concrete load as well to the structure. So we're just going to put the wet concrete in first. This will be important for this construction stage analysis to be carried out. Okay, you see the loads have been applied there. So let's do the surfacing next. Set that as 5. And now we just do the parapet loading as well. So it would just be to the 2 outside girders. So set that as 10. So now we're going to focus on the temperature loading. So I'm just going to quickly select the bridge deck and element temperature loading. And we just set the final temperature, and we've already got the initial temperature set in there. Click apply. So that's our temperature loading on the structure. Okay, now I'm gonna go on to do the construction stage analysis. So as you see, I've already formulated the groups to go in there to do this, to save time for this demonstration. So we're just going to create the stages. So let's go on the add, and we're going to call the first stage stage 1. Now we're going to have just the abutment and piles, and our boundary conditions are going to be the supports, and our loading is going to be the dead load. So that's our first stage complete. We just do stage 2. So it will be all the steel girders. Just give that a duration of 7 days. Our load is our wet concrete because it's not set yet. And stage 3 will be our deck. Now we can take off the wet concrete. And that'll be in the deactivated section. And now stage 4, which is just where we put all our loads and surfacing everything on there in the parapets. And we give that a nominal length of time in the form of a few years. Okay, that our construction stages have now been created. So now we're going to deal with the composite section and make sure that, because it's at the moment it's only one element, we want to split it out into two. So we just split them over different construction stages. So we go to stage 1, and you can see the main span's been selected there. And we just want to select it by the material and make sure we've got the steel. And we activate that in stage 2, and then the concrete will go into stage 3. So we want to give that an age of 7 days. Okay. So I've already done this for the ends of the tapers, so the left and the right end. And now I'm just going to show you, I'm going to open up the next model and show you the complete construction stage, all the construction stage being carried out. So we just go into the realistic view and just show you the construction stages. So stage 1, abutments and piles. Stage 2, you can see the steel deck. And stage 3, you can see the concrete deck being put on top. You can also see the spring supports and the loads on the structure as well. So it's the parapet loads. Then we can look at these through the construction stages as well. So I'm just going to go on to the moving loads and do the code. So we just got to select Eurocode. Then we get to do the traffic lanes. So let's select the deck and isolate it. So go back to the wire view, go to traffic lanes, and we're just going to define all our traffic lanes. So first lane 1. Okay, just some distances. Going to do the cross beams and have it so where it affects the cross members. And we just got our start point, so we want to select this side of the structure and have the measurement of 4 meters going from this side. Now we're going to do lane 2. So just delete all the previous information, select the start and end point. Then we have our lane 2, and then we're just going to do the remaining area. Let's delete the previous. I just want to put a smaller lane width in. Click apply. So we just do the remaining area 2, and this will be shown in a moment, and when I put the vehicles on it, why this become important. Okay, so we've got the 2 remaining areas, we've got 2 lanes. Now we select our vehicles. So just we got the code, and we just select what vehicle we want. We can also change adjust some of the factors for the national annexes. You can see. Now we want load case 3 and the UK national annex for special vehicles, so we're going to select SV196, and I'm going to rename this to the vehicle load name. Then we're just going to focus on the moving load cases, so I'm just going to add one here. So this is the moving load case 1. So we just select all the lanes, and the remaining area will go into the remaining area box. Just click apply. Then we just do it for LM1 plus LM3. This is where the vehicle will straddle 2 lanes. Okay, so we just put the straddling lanes there. Now we're going to do the load combinations, so I'll just quickly go over and show you these. So we've got steel first of all we'll focus on. So we can hit the auto generate button, and you can see from the drop down menu we've got Eurocode in there. We can change some of the load factors. We can also have the traffic loads, make sure we've got the frequent value and the characteristic value separated. The maximum load. As you see, we've got our serviceability and also our strength checks. Do the same for concrete. So select the code. You see we can change some of the load factors to what we did last time, and we can also take over the frequent value. So okay, so they've all been created, and we've got our serviceability and strength checks and all of our different descriptions there for the values. So now I'm going to go back to the presentation. We're going to look at the analysis capabilities. So what we're going to discuss here, what we're going to show you, is the static analysis, the live load optimization. We're also going to look at the automatic creation of static load cases, and then we're going to go on to look at the bending moment diagrams and the beam stress diagrams as well in the top and bottom flanges. So this is the complete analyzed model, and I'm going to look through the reactions first. So we just selected one of the load cases, just stick with the dead load. We can pull up the values and also the legend as well. So we have all our reactions. Also look at the displacement contours, and we can look at these through the construction stages as well. So go back to stage 1. We just want to select one of the low cases, and we can look at the creep. We can also look at the shrinkage as well. We can look at the summation of everything. So we look at the real deformation. So you can see the deformation. We can go through the construction stages. So we can look at the bending moment diagrams as well. So I'm just going to quickly select that. We can go through the stages much like we did previously. Then we can change some of the parameters, so we can look at solid fill. Just go through the stages. So we see all our bending moment diagrams for all of our girders and also the piles. Then you can just take that through each individual stage. We can also look at the different components as well in the form of the steel and the concrete. We can look at that in the different stages, so that is the concrete in stage 3 and 4. So now we look at the stresses in the girders. So we can look at the top and bottom flange. You can also look at the different parts as well in the form of the steel and the concrete. Just look at that from the side view. There's the stresses there. Go for solid fill. Then we can look at that in the bottom flange as well. So I'm just going to quickly go through the moving tracer and the beam force and moments. So we're just going to pick one of the elements along the structure and the different moving load case, and what we're going to do is we're going to make this into a static load case. So I'll just get rid of some of the contour lines. As you see, this is the optimum location for the vehicles. And that's marked out in the red dots, very detailed. So now we're going to continue on to design. I'm going to go back into the presentation. So during the design part of the presentation, the demonstration, sorry, we're going to focus on the design of the composite plate girders, so the steel girders in the reinforced concrete deck, and we're also going to look at the design of the reinforced concrete piles. So I'm just going to take you back into the graphic user interface now. I've just redrawn that, and composite design, then we're going to do the design parameters. So we can change any of the parameters in this field, and we've also got the ultimate limit state at the bottom and the serviceability limit state. So we're going to look at the longitudinal reinforcement. So we can pick the midspan, and this is what we're going to select, and we can give it a cover. I'm going to change the units there. So it's 50 millimeters. And we can do the starting point and the end point. And then we just put how many bars we want along that length. We can also select the diameter of the bars. We do the top and also the bottom. Thus the reinforcement's been defined. So now we're going to look at the stiffener plates. So that's for the midspan, and we've got some other values. So we've got the width, we've also got the thickness. We've also got the space in between the two as well. So we're going to do shear connectors, so we can do the number of connectors, got all the different parameters we can fill out. Okay, and we just do the diameter. Also got the tensile strength I just put in then, and the overall height. We also do the spacing. We just select the elements we want this to be applied to. Okay, and then we just continue, and then we do the design results table for the bending resistance. So you see here that we've got them all, the classes have been separated out for the different elements. We can also look at that table in the printed results in the form of an Excel sheet. So I'm just going to load up the previous Excel sheet that I've created. So this is the Excel sheet of the results. So we're just going to go down through some of the main parameters here. So we do the crack stiffness. We can also do the bending resistance is in this report. We can move on down through. We also do the classification of the section as well. So we do the resistance to vertical shear. We also do the resistance to lateral torsional buckling. And as you know, it will actually give you the code. You can see the calculation within the sheet as well. Resistance to fatigue, stress limitation, longitudinal shear as well for the serviceability limit state. So now we're going to focus on the design of the reinforced concrete piles. So we're just going to do a column check. It'll take a couple of seconds. So it's just selecting every single member within the working space. As you see here, we've got our section now. So here are all our different members. We can highlight that if it is highlighted in blue, then it's a passive section. If it's got some red in it, then that means it's failing as per some of the code. So we can draw the PM interaction curve. We can also look at the graphic, which is a one-page summary report. Okay. We can also look at the detailed report as well, which is as per the Eurocode. There you go. So now what we're going to show you is the dynamic report. So I'm just going to take you back into the presentation. So this is a dynamic report, and I will show you why it's so dynamic, but what we'll do in this section is I'll show you the reports tree where all of your images go. Then we'll just show you some of the drag and drop functionality where we can take it from the reports tree into the Word document and the automatic generation. So just go back into the modeling space now. So I'm just going to save a few of the images, so isometric view. Then we can look at the also some of the reactions and deformations and bending moments. So here's some of the tables. So these are reactions. You can use the auto sorting function to take the worst case to the top. We can save that into dynamic report. Right, so all that's gone over into a reports tree. I just look at some of the deformations. I'll quickly do these. So we click at deformation. Exactly the same principle, just save it into this is just a simple right click and dynamic report. Okay, there's some of our bending moment diagrams. We just save that into dynamic report as well. Okay, now go to Tools and Dynamic Report Generator, and we're ready to put everything over into our report. So this is a Word document that will open up within the MIDAS Civil Graphic User Interface, and we simply drag and drop everything over from the works tree into the report. First of all, I'll just put a bit of text to show you can edit it, but it is Word, so you can put your headers first. You can load up your previously defined documents. So just drag and drop the isometric view. Displacements. Also the beam diagrams as well. So I just want to bring across a few tables. So here's the reactions table. Then we can do the midspan, we can do the sections, so show you before the concrete is placed on top and also after. And give you all the material, all the properties as well. The properties of the section, so your IXX and IYY. We can even do the load combinations and a mini bill of quantities as well, just a basic output of the quantity of material used. So now that I've showed you that, we can go back into the presentation and just close. So thank you for attending. We have devised a video lesson which we will be uploading to YouTube and sending out. This whole program that we've done here, but it's an hour and a half long, and it gives you a detailed account of how to do the modelling right the way from the first node all the way through to the dynamic report at the end. We've gone over our half an hour allowance. We have had a few questions come in, but I do assure those of you who have sent these questions in, we will be replying by email immediately after the webinar. I'd just like to say thank you to everybody that attended. We had a great turnout today, and please do come along to our next session, and we'll be happy to see you. So just thank you again. I've been Adam Kane, and if you do want to contact us, the contact details are on the screen. I will leave them up for a couple of minutes now. All right, thank you.